Hello, dear students. I noticed that the exercises about stoichiometry were a little difficult for you. So I'm making this video in order to explain you a little more, give you more examples, because this will be in the third exam. Well, in the first case, I want you to know how to go from mass to moles and how to go from moles to atoms. In order to go from mass to moles, I have to divide by the molar mass. If it is an atom, you will use the atomic mass that is in the periodic table. If it is a compound, you have to calculate the molar mass. When you have moles of the atom using Avogadro's number, you can go from moles to number of atoms. In this case, a piece of copper that is 5 grams. And look, I put 5.00. This number has 3 significant figures. Well, I know that 1 mole of copper is 63.55 grams from the periodic table. And later, I know that 1 mole of any compound, any element, contains 6.022 times 10 to the 23rd atoms. So I multiply 5 by 6022 times 10 to the 23rd, and I divide it by 63.55. I cancel grams with grams, mole with mole, and the answer will be in atoms. As you can see, the answer has 1, 2, 3 significant figures as the given number. This is very important because sometimes you say, I am giving the right answer, but the Cengage says that I'm wrong. Well, the problem is that if you don't report the number of significant figures, they will consider that your answer is wrong. Got it? Well, here we have another example. In this example, I am trying to go from mass to moles. And you know that we have to divide by the molar mass. But in this case, it's not an element. Then I cannot take it from the periodic table. It is a compound. And this compound has 2 atoms of carbon, 5 of hydrogen, 2 of oxygen, and 1 of nitrogen. If you multiply the number of atoms of each by the atomic mass that is in the periodic table for each of the elements, and later you sum all the results, you get the molar mass of this compound. Well, the problem says that you have 28.35 grams of glycine. So you divide by the molar mass and you get number of mole. Look at here. In this exercise, there is a mistake. The number of mole, the given number, it has four significant figures. So if you divide 28.35 by 75.07, you will get 0.33 and then 7. You have to report 4 significant figures are in the given number. Then it is wrong. The right number is 0.37 6 mole of glycine. Because this number has 1, 2, 3, 4 significant figures as the given number. Let's go. Well, let me stop before I go to the following problem. When you want to go from the mass of a compound to the number of moles of this compound, you have to divide by the molar mass of the compound. And in this case, you have to calculate the molar mass of the compound using the number of atoms in the compound of each element and the corresponding atomic mass in the periodic table. In this case, I want to go from moles to mass. It's the opposite. Well, in this case, you have to multiply by the molar mass. In this case is C vitamin. Well, you have the number of moles, and then you multiply by the molar mass of this compound. You cancel mole with mole, and in your answer you have 0.0250 grams of vitamin. Look, in this case, the given number has 3 significant figures, and the answer contains 3 significant figures. Remember that the zeros to the left are not significant. Now, in the following problem, you have a reaction. Well, in this case, that you have a reaction, the first step is to balance this equation. Because these numbers that are in front of all the compounds, in this case, the reactants, and here the products, these numbers represent the number of moles for each of them. And it is used in the calculations. Look at this. How many moles of silver, this is a question, moles of silver are needed to react with 40 moles of nitric acid? Well, the given number is 40 moles of nitric acid, only one significant figure. And then you multiply by the ratio of moles in the equation. Down, you write moles of nitric acid, that is, in this case, as you can see, 4 moles. Then you write here the number 4 and 3 moles of silver. These are from the equation, okay? So you cancel up moles of nitric acid with mole of nitric acid, and your answer is in moles of silver. Then you multiply and divide, and you get 30. You report 30. This number has only one significant figure, and the given one only one significant figure. Then it is okay. Here I have another example that is about the same. But in this case, what happened? That they are asking about the moles of silver nitrate that are produced in this reaction from 40 moles of nitric acid. In this case, you take the 4 for nitric acid and the 3 for silver nitrate. You cancel up moles of nitric acid with mole of nitric acid, and you get your answer in moles of silver nitrate. That is the question. Here you have another example. You can stop the video and you can see, but it's another example of the same thing. Yes, I wanted to show you that you can use different combination of elements, reactant with reactant, reactant with products, product with products in these calculations. Another example, you can stop the video and you can see how I solve the problem. Let's continue. Well, in this case, the problem is different because I am asking about the theoretical yield of ammonia in kilogram that we can synthesize from 5.22 kilograms of hydrogen. Look, here we have one of the reactant, hydrogen, and 31.5 kilograms of nitrogen. Well, in this case, what you have to do, you have to do the calculation for one of the compounds, and you get the grams that you get from the production of, in this case, hydrogen. But later you have to do the same operation for the other compound. In this case, it's 31.5 kilograms of nitrogen. And you know that 1 mole of nitrogen is 26 grams of nitrogen. And because it's the diatomic molecule, okay? So you know by the equation that 1 mole of nitrogen can produce how many? 2 moles of ammonia, NH3. But you're not interested in the number of moles of ammonia. You are interested in what? You are interested in grams of ammonia, NH3. And you know that 1 mole of ammonia, well, we calculated it before, is 16 grams of ammonia. So what you do? You multiply 31.5 kilograms of nitrogen by 2 moles of ammonia by 16 grams of ammonia, and then you divide it by 26 grams of nitrogen, and the answer is 38.8. Then the answer is 38.8 grams of ammonia. What is the next step? Well, the next step is to compare how much can you can produce from nitrogen and how much you can produce from hydrogen. As you can see, you can produce less ammonia from this amount of hydrogen. So you consider that hydrogen is the limiting reactant, and the amount that you can produce of ammonia from this amount of hydrogen is the theoretical yield. Remember, you compare the results that the amounts of product that you can produce from each of the elements or compounds that are given, and you choose the smaller one. What does it mean? That hydrogen will limit the reaction. When hydrogen is over, you will have some nitrogen that is not in the reaction. That's an excess. Well, you can stop the video and do it by yourself in order to understand this kind of exercise. Now, let's go to another one. In this case, we have a reaction between potassium oxide, in this case, peroxide, sorry, and you have water, and the reaction will produce potassium hydroxide and will release oxygen from the peroxide. Well, what you are going to do in this case, first of all, see if the equation is balanced. Is balanced? Yes, it is. Now, you will calculate the amount of oxygen that will be produced from 120 grams of potassium peroxide, and following the procedure that I showed you before. You can stop the video and see what I have done here. And the same way, you will calculate the amount of oxygen that will be produced from this amount of water. These are the two reactants. And oxygen is one of the products. If you compare both amounts of oxygen, you will see that you will produce less amount of oxygen from 120 grams of potassium peroxide. So this is the theoretical yield, and potassium peroxide is the limiting reactant. If I tell you that in the real life I only got 35.2 grams of oxygen, then what is the percent yield? I divide the actual yield, that is 35.2 grams of oxygen, by the theoretical, the one that I calculated from the equation, that is 40.51. And I multiply by 100, and I get that the percent yield is 86.9. Stop the video and try to do this exercise by yourself. Let's go to the following exercise. Well, in this case, you have that the combustion reaction is when we have for example, we have a fuel, and in presence of oxygen produces a carbon dioxide and water. Every time I have a fuel and is in the combustion reaction, the products will be CO2 and water. You know that CO2 is one of the gases that is producing the increasing of the temperature in the planet. So it's very important, this exercise, not only because it's a chemical reaction, but because we have to do this calculation to control the amount of carbon dioxide that we produce. Because of the use of fuels like petroleum or like carbon? Well, in this case, you have to go to this reaction. For example, octane is gas. Is the one that we use in our cars. In presence of oxygen produces CO2 and water. You have to balance the equation. Don't forget that you need to balance the equation in order to get the ratios of the reactants and products in the chemical reaction. Well, here we have an example with another gas. In this case is pentane. Pentane, in presence of oxygen, produces CO2 and water. I balance the chemical equation, and I am giving you that how many grams of carbon dioxide can I produce from the combustion of 100 grams of pentane? Well, in this case, you multiply 100, that is a given number, by or divide by the molar mass of this compound in order to convert this into moles. And later you use the ratio between pentane and the carbon dioxide that is produced. These are the coefficients in front of the equation. This is the ratio. And later you convert more these moles of carbon dioxide into grams of carbon dioxide, multiplying by the molar mass of carbon dioxide. Then the answer is from 100 grams of pentane, you can produce 305.56 grams of carbon dioxide. Well, as you can see, the number of significant figures here is only one. I am giving here a lot. Then the answer will be yes, 300 grams of carbon dioxide. That is the closer number to the one that I got from the calculator that has only one significant figure. In order to report the same number of significant figures in the answer than in the given number. Well, that's all. If you still have some problems, don't hesitate. Send me an email and we can have a meeting face-to-face by Zoom. Goodbye.